Good morning, developers. Let's start developing. My name is Vekoslav, and today we're gonna be taking on the last task of the first decade of the Advent of Code 2021. So that's the 10th task. And to be honest, I have to admit that I've taken a peek at the text of the task, and we basically get to play the favorite game of each and every developer, and that is called Find the Missing Parentheses. And of course, we have parentheses, we have braces, we have brackets. No, these are brackets, these are braces, and these are angle brackets or something like that. So we have four different sets of matching characters, and we are giving some input when some of them are missing. What they trying are actually defining that we have two different situations here. We have some situations when we have incomplete, so to say, lines. Let's take this line for example, because we are starting with that and that and that and that and that and that and that is matched, so we're matching that one, and that is matched, and that is matched as well. And then we have these, and then we have that. Those are matched, those are matched, that is matched. And this is just a simple situation of a line being incomplete. So everything we've seen so far is valid, but it just doesn't end. So we are told to ignore these things for the first part. Well, okay, that means that we're gonna get to have fun with them for the second part most likely, and I kinda expected that we will be able try to finish this, so to say. And the other combination, the other issue is that we have lines like this. So that's a match, and then we have that, and that is a match, and you can see that we have a mismatch here, that we are starting with a brace and end on a bracket. I'm gonna call this one brace and this one a bracket because I honestly don't know or care which one is which, but the good thing is they are different. So we will need to parse this somehow. And here is one of the places when people will say, oh, we can use regular expression. No. Please don't use regular expressions for this, but because that way lies madness. This is a natively recursive, so to say, structure, because within each set of parentheses we can have another set and another set and another set, and in theory you could build an extremely complicated regular expression and extremely fragile regular expression that will try to match this, but it's not gonna be fun for anybody. What works better for this kind of scenarios is basically a simple structure called a stack. So, first of all, we will need to read our input, and this is our input. Okay, let's start with the obvious things first. We will need to read our lines, and I will actually call these lines. We're just returning them because that's our input, so it's not an array of numbers, it's an array of strings. So for part 1, well, what we need to do, well, we're just gonna say filter out all the lines, well, is valid line is not true. Yep, only one thing missing, that we need to say whether the line is valid. Okay, and if we just say return false, that works. Actually, I'm not gonna call this is valid, I'm gonna call this parse line. And this will return a parse result. So what is a parse result? What I'm gonna do right here is use a trick I use often, so I'm gonna have a few results. This will be an invalid parse result, and an invalid parse result is basically has success false. So yeah, we can have the line string anywhere, and we can have the error index, because we need to find where the parsing failed. So we, for example, for the first line we expected a closing brace, but found a closing bracket. Yeah, and we're actually counting these, so we need that character. Yep. Why do we need the line? We're just echoing it, but let's have it. And we have success true. So far, let's have it at that. And I will declare that a parse result is just invalid parse result or a valid parse result. So we're gonna return, let's say if everything is valid, return the line and say that it's valid. Yeah, I can use this, but to be honest, I understand this better. So we're just gonna parse, and we're just gonna say the invalids are filtered them by parse result, where parse result dot success is not true. Those are the invalids, and then of course we will have to have this, the costs. Well, basically the cost, we have this table of these is, yeah, well, those four characters kind of go together, so we have 3 and then 57 and then 1197 and then 25,137. Okay. So what we need to do for the invalids? Well, we need to map them for each parse result. We will need sense the parse result here is we are filtering it, but right now this is not known to be an invalid parse result, but it will be an invalid parse result because we already filtered this. So here we will need to just say that this is an array of invalid parse results. Parse results dot line of parse results dot error index. So we're mapping it to the character that caused the error, and then we're doing that. Yeah. And then we are basically adding all the costs, and we are getting our result. Result is a number, so that we can just why this is any initial value is quite obviously a number. Because costs of this might return undefined. Who knows? Hopefully it won't. So if we run this will totally return everything that we need, but it will return 0 because by default we said that yay, everything is valid. So now we changed our problem into basically another one. We need to determine if a line is valid or not. How do we do that? We're gonna use a structure called a stack when we are basically pushing data. Push this, then push this, then push this. So each time we encounter an opening character, we are pushing it, and each time we encounter a closing character, we are popping it. So that way we are basically taking care of the level where we are at. So that's why we know that this will be on the same level of this. This too will be on the same level as well, and this will be one level down, for example. But here we will stop the processing because we have an invalid thingy. And we can check that we have an invalid thingy because we had this and we needed to match it with this, and we were not able to. So what we will basically do, if we encounter a pair, we're deleting both. If we encounter a pair, we're deleting both. And this is not a pair, and that's it. Yeah. One other way that might work, that might be a bit simpler, and let's use Excel for that once more, and just copy, paste here, and then paste here, and then paste here. And let's try this. We can say replace, if we have such a string, I have no idea what this is, with an empty string. Okay, I don't know Excel enough. But what I'm saying is that we can go in and replace all the matching parentheses. and we're continuing deleting each time that we see something matching. So yeah, we are left only with starting characters, so this is okay. Delete, 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 delete. Now delete this. Starting. Yay, delete, delete, delete. Only starting characters, this is valid. We had a pair, delete. We had a pair, delete. We have a pair, delete. Delete. So we're not thinking too much. Delete, delete. And this doesn't have a pair, only opening characters, so we have an error. And so on and so forth. But this will give me a bit less information about exactly where the problem is. So I will try to have it with a stack and see if I'm able to do this. So for each line, actually I'm gonna need an index. Well, yeah, Copilot wrote some code for me that I think is somewhat connected with what I wanted to write. I'm gonna call this index, I'm gonna call this character. So we have the character at line index. If it is an opening character, or if it's in one of these four, and actually I'm gonna do this way. Const opening openers is a better name, and an opener will also include this one. Closers are that one, those ones. So we can just say if openers include the character, push it to the stack. Else if, and else if it's not a closer and it's not an opener. Whoa. Didn't need that. We'll need something like that, but not exactly that. If it's not an opener and it's not a closer, then it's, I don't know what it is. We don't want to, yeah, we do want to pop it. Yeah, this is what we actually want to do. So, if we encounter an opener, we're pushing it onto the stack. And when we encounter a closer, we're popping one from the stack. And if the opener, it's not the corresponding opener to the same closer, because this is the index of the closer. Let's have it a bit clearer. Because we have the corresponding 0, 0, 1, 1, 2, 2, 3, 3, and so on. So we're getting the index of the closer and see if it's the matching one. If it's not the matching one, then it's simple. We have an invalid, and the error index is right at the position of the closer. Otherwise, if we manage to go through everything, well, this is a success. So let's see what this does. 26,397. The expected result was 26,397. Yeah, looks like we're on the right path. We only need to take the huge input instead. Yep. And let's try using that. Well, it kind of finished and it says that this is our result. Let's see, did we got it right? That's not the right answer. So we have an error somewhere. Well, now we need to debug. It sounded too easy, to be honest. Well, one thing that I will want to check is that I have the input correctly. Copy, paste. 94 lines and they seem like they're running okay. Let's see the input. 94 lines and they seem to be running okay. So now we are back to the drawing board. Let's see how many parsed lines there we had. So this is everything. We have error, 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 success, true, error, error. Let's just get the counts first. We have 47 wrong out of 97. Let's take a look at this. Do we have a good closer for a error index? Maybe we're getting something weird. Closer, 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 closer. Looks like it's okay. 34773. Was that the answer that we tried? Not sure actually. Let's try it one more time. We are getting a time penalty each time we're trying an incorrect answer. Yes. So I will just copy it here so that we're not risking it again. And this one actually said that the answer is too low. Looks like we're getting those closures, and so let's group them. Yeah, I have a group by function as well that I'm using, and that will give me something. Oh, I actually don't need group by, I need group reduce. Not that one. I just need to count them. This one is not needed. So we have 14 this, 13 out of those, and the calculation would be maybe we messed up the calculation. Let's do that, and that we can do in Excel much better. So we have these 14, these 13, these 11, and 9 of these. And let's see what the prices were. For a parenthesis, we're getting 3 points, 57 for this one, 1197 for this one, and 25,137 for this one. This times this, that's that much, and if we sum them out, what? To be honest, I definitely didn't expect this to give me a different result than this. This is terribly confusing. So we're just gonna group them by an error, and we have the key and the count, and we can just say error groups dot reduce each error group. So we're not gonna add the value, we're gonna add the value times costs of the current dot key 0. Yeah, that's the result too. Let's see what the result 2 will be. 340,773. 340,773. We either made some typo somewhere. 3, 3, 57, 57, 1197, 1197, 25, 137, 25, 137. So somebody doesn't know how to multiply. Either that or 14, 14, 13, 13, 11, 11, 9, 9. Are we missing one of those, or let's log the error groups once more, see if we are missing something. And we have 47 invalids. 14, 13, 11, 9. 14, 13, 11, 9. What's the difference between these two numbers? $320. How is this gotten to? This is a weird difference because we're kinda having only prime numbers here. Is this divisible by 57? Yeah, it's 60. Is this divisible by this? I don't think so. No, even these two are, if this is correct, and it looks like it's correct, 14 times 1200 is about to be something like that. This is 13 times. So I guess we're missing something. You know what? I'm gonna assume that we have an error in our reduce functions because nobody understands reduce functions. So let's just say after we map them and we reduce them, we map this again. And we map this to a object that has key costs of g.key, costs of g of key, and size g.value, and log that. Let's have result 2 equal -1 so that it compiles. Let's see what we have. And as long as we're taking it slow, let's map it one more time. So the key is the key, the size is the size, and we add one more thing, that's cost, that's key times size. And what we're missing, yeah, g.key. Actually, we don't need this. We can just say give me the G. $7.98. Oh, somewhere somebody screwed up the costs. That should be it. So the cost of a parenthesis is 3. The cost of this is 57. And the cost of this is 197. And how do we get this correct? Oh, we had the same number of this was found once and this one found once, so we got the number correct. Yeah, okay, mystery solved. It's not that we are not understanding the reduce, is basically that we have no idea how to write from one screen to the next. 344,193. Yep, so Excel knows how to count. But let's see if that is correct. And that is the correct answer because we managed to have a wrong thingy. Now, discard the corrupted lines. The remaining lines are incomplete. Incomplete lines don't have any incorrect characters, instead they're missing some closing characters at the end of the line. To repair the navigation sequence of closing characters, they complete all open chunks in the line. You can only use closing characters, or you must add them in the correct order, so all chunks are random closed. Okay. How to complete? The score completion string character versus character. Start with a total string of 0. Score. For each character, multiply the total score by 5 and then increase the total score by... Again this table, I'm gonna screw it up again. Let's copy this for the second part and let's be really careful that we don't mess it up. So this one is 1. That one is 1. The next one is brace and that is 2. And the next one is that and that is 3, and the angle bracket is 4. Okay, hopefully this is okay. So how do we scoring it? How are we scoring it? Start for each character, multiply the total score by 5, increase the total score by the point value given for the character in the following table. So we're kind of constructing a string in modulo in radix base 5. Okay. Add the value of 2, multiply by 5, add the value, multiply by 5, add the value, multiply by 5, add the value. Okay. Sorting all of the score and taking the median. Well, yeah, we can do that. So, one way to do that, we can actually improve our parsing score, parsing method. And I think that we're gonna do that for the valid ones. For the valid ones, we're gonna add a completion. That's gonna be a string. So then that will be basically, so what everything that is left on the stack when we are done is basically what we actually need. So we're just gonna add everything on the stack as the completion, but we're not gonna do it this way because this will be wrong. But let's just go back to the small example, and we managed to do this. We start with this and let's see what we should get. So we have this, and this will pop each other off, and this will pop each other off, and this will pop, and this will pop as well. So we have this, we have this, we have this, this will, and all of these will pop off. So this is the content of our stack, and we don't actually want to do this because we want to do it the other way around. So what we want to do, we would want to, let's start with this anyway. We don't need this one, so logs. We don't need the parsed ones, we need the valids. And let's see. Valids of 0 dot completion. Yeah, this is exactly what we started with, what we had. Tut, 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 tut. And is totally not what we want. But what we want to do is we want to have something that complements this. So we want to do it the other way around. So we're gonna do two things. First, we're gonna reverse this. Yeah, so we have it the other way around. It is correctly reversed, so we have the complementary thingies, and that's cool. So now, no, we not only need to reverse it, we need to change it. So we need to map each character into the corresponding closer character. Closers of openers dot index of character. So we're getting the index of the opening character and looking it up into the closers. And only then we will join everything together. And let's see what we get. Where we're getting this. And Notepad++ is even nice that it tries to match parentheses for us. As I said, that's the one of the most exciting developers games that every developers love playing, and even if they don't love playing it, they're still gonna play it a lot of times. But this is operational. But now that I think of it, we don't really need to join it, we just need it. So this won't be just be a string, it can be an array of characters, which we don't have in JavaScript, so we're just gonna be an array of strings. So, assuming that we have all the valid competitions, well, competitions, now we just need to score them. So we're just gonna get a competition and return a number. The costs will actually be a constant here. And what we know, we don't want to do that. We're gonna reduce it, but the reduce process will be quite a bit different. So we need to multiply the accumulator by 5 and then add the cost. Okay. This is the scores, is valids. Yep. Let's log the scores. 288,957, 5566, 148789, 995, 444, 294. Looks like we are onto something. And then, as said, then we just need to sort them in that order. Let's see. And we have our middle one, and that means that we can get the middle one. And result is the middle one. As they said, there will always be an odd number of scores to consider, which means that if we have a length of 5 like we had here, we need 1/2 of 5. We need 1/2 of 5 plus 1. So 1/2 of plus 1 divided by 2. So this might be subject to some rounding errors, but it shouldn't be because we are running with small numbers. Anyway, if we get a result, back. Okay, we don't need the result of 3 because this is 5 plus 1. 6 divided by 2, we got a score that we need the third one, we don't need the score of 3. The third one is 2. So we need to go the other way. Yay, that's the one. And if we pop in the huge input, let's see. That's a large number. It might be correct. Who knows? And that's the right answer. And we are off. We have fixed the navigation system, or what is, yeah, the navigation subsystem. That means that next tomorrow we're gonna get one more maze, I think. I just have a feeling about that. Let's see how fast this took. I don't think I have any missing console logs. Let's go here and run this. You can see that it took basically an insignificant amount of time. Part 1 was 2 milliseconds, part 2 was 3 milliseconds, and don't forget that for each of the parts I'm parsing the data anew. We don't need to do that. We can parse them just once. But I want the first part and the second part to be able to be run independently, so and I don't want to put all of that parsing in the processing of the input because the parsing is actually part of the processing, it's not part of the input. The input is quite nice strings. So we have the parse line helper, we have the score completion, that to be honest turned out to be a bit easier than what I thought. So we might have even written it in line. So, but anyway, that's not a problem. And we have two quite simple pieces of code that nonetheless gives us the correct results once you get your price mapping right. Yeah, so there was a small bug that made it hard for us to solve it, but unfortunately we used some tools like Excel that managed to convince us that we basically don't know how to add and multiply. The error was not in the algorithm itself, the error was mostly in the post processing and post calculation. So that's it from me, and see you tomorrow. Bye.